About graphing quadratics. So remember, quadratics are the ones with the x squareds, right? It's going to be just one single polynomial looking thing where it has x squared as the highest degree. And we need to find the features of it, and we need to be able to graph it, okay? So when we are graphing quadratics in this form, the first thing we're going to look for is the axis of symmetry. Remember, we use the formula x equals negative b over 2 times a for that. So first, let's identify our a, b, and c here, right? So our a is going to be 1, right? Remember, this is written in the form ax squared plus bx plus c, where a, b, and c are the numbers in front of the x's. It does not include the x. So here, there's nothing in front of the x squared, so that's going to be just a 1, right? If there's no number, it's a 1. B is 6, and c is 5. So if we're doing x equals negative b over 2 times a, right? So negative b would be negative 6, so negative 6 over 2 times a, which is 1, right? Is going to give us negative 6 over 2, which gives us negative 3. So my axis of symmetry is going to be x equals negative 3. Remember this x equals part, okay? You need this. It will not get full points on the test if you do not have the x equals part with the axis of symmetry. Now, after that, we're going to find our vertex. And to do that, we need to plug in the axis of symmetry to the equation. Now, when we find our axis of symmetry, that negative 3, that's also going to be the first part of our vertex. So now we're going to take that negative 3 and plug it in. So our equation is x squared plus 6x plus 5. So we're going to do negative 3 squared plus 6 times negative 3 plus 5, right? Remember, x squared, 6x plus 5. All we did is replace x with negative 3, right? Because that's what we got for our axis of symmetry. Now negative 3 squared, that's going to become 9 plus 6 times 3 is going to give us negative 18 plus 5. 9 minus 18 will give us a negative 9 plus 5 will give us a negative 4. So when we plugged in negative 3, we got negative 4. So that is our vertex. I'm going to erase this, so pause it if you need to. So then, the next thing we look for is our axis, not our axis of symmetry, our maximum or our minimum. So to do that, it's 2 parts, okay? We need to identify, number 1, whether it's a maximum or a minimum, and then we need to identify what the value is. And remember, for that, we write y equals, and again, important, we need that y equals part. So, to tell if it's a maximum or a minimum, we need to look at the first term, the ax squared part. Now, if there is a minus in front, right, if a is negative, then we have a maximum, negative a, right? If there's no minus, right, there's no minus in front here, then we have a minimum, right, just plain x squared. So basically, if you want to think about it maybe like this, it's maximum if it says negative x squared, and it's a minimum if it says just x squared. And then the value of it is the same thing we just got for the vertex. So it's going to be y equals negative 4. And then lastly, we need to find the y-intercept, which is arguably the easiest part to find because that is just our c, right? 0, c. Our c is 5, so our y-intercept here will be 0, 5. So now that I've found all these features, I'm going to take this and graph it, right? So first I'm going to start with my vertex. So negative 3, negative 4. Let's look at our graph. So remember, it's an x, y. So on my x-axis, I'm going to go to negative 3. So it's going to be 1, 2, 3, negative 3. And then on my y-axis, I'm going to go to negative 4. So negative 1, 2, 3, 4. And right here is going to be my vertex. Now, I'm also going to draw my axis of symmetry through my vertex. Now remember, it's an invisible line, so you don't need it on your graph, but it does kind of help us reflect the points as we're graphing. If you do include it on your graph, make sure that it's a dashed line and not a solid line. So make sure you write it like I do. Now, we did our vertex. The second thing we're going to do is the y-intercept, which is at 0, 5. So that means we're going to go at 5 on the y-axis, which is going to be 1, 2, 3, 4, 5. So it's going to be right here. Now, we're going to reflect that point, right? And then plus reflect. So we see that the y-intercept is 1, 2, 3 boxes away from our our axis of symmetry. So it's going to be 1, 2, 3 boxes away on the other side too. So now we have 3 points, but we need 5. So the next thing we're going to do, you know what I forgot? I forgot about the x-intercepts. Let's talk about that real quick, because we're going to use the x-intercepts for our graph here. So the x-intercepts, we have to factor and set to 0. So our equation is x squared plus 6x plus 5. So what factors of 5 give us 6? Well, that's going to be 5 and 1, right? So x plus 1 times x plus 5. Set those equal to 0. X plus 1 equals 0. And x plus 5 equals 0. And I get x equals -1. And x equals -5. So that means my x-intercepts are at x equals -1 and -5. So to find the x-intercepts, you factor and set those factors equal to 0. And when you solve that, those numbers are your x-intercepts, meaning that's where it's touching the x-axis. So if our x-intercepts are at -1 and 5, so we're going to go to -1 on the x-axis, which is right here, and then -5 on the x-axis, which is right here. And that gives us 5 points. And now we can connect them, right? We're going to connect these dots. And there we go, that is our graph. Now, make sure that the graph is curved like a U shape or an N shape if it's upside down. It should not be a V shape. That is not good because that's a different type of graph. We don't want it like that. So remember, it needs to be curved like a U or upside down like an N. Now, let's also talk about what if we can't find the x-intercepts though, because remember, we only find the x-intercepts if we can factor, right? If it's factorable. So I'll tell you right now, on your test, 1 will be factorable, but 1 will not be. So if we can't factor, then what we need to do is instead plug in a number on the x-axis in between our vertex right here and our y-intercept here, right? So in between -3 and 0, we can plug in to our equation to find a new point. Similar to how we did with our vertex, right? So we pick a number for x. Let's pick -2, right? Because we already have one, -1, so let's say -2. And then we plug that into our equation, right? Which again is x squared plus 6x plus 5. So we're going to plug in -2 and solve. -2 squared gives us 4. 6 times -2 will give us a -12, and then a plus 5. 4 minus 12 will give us a -8, plus 5 gives us a -3. So when we plugged in -2, we got -3, right? So that means that -2, -3 is a point on our graph. So x equals -2, down 1, 2, 3, right there. And then we reflect that right there. So our graph was pretty decent. So if you can't find your x-intercepts, that's how you find your 4th and 5th point, okay? You just plug in, you pick a number in between your vertex and the y-intercept to plug in for x. Typically, you can use 1 or -1, and it's since that's easy to multiply by 1 and -1. And then the number you get is the number for your y, right? Again, it's the same process as what you're doing when you're finding your vertex, okay? So if it feels confusing, just remember it's like finding a vertex, just a different point on the graph. You're plugging in a different number for x, and then when you get the answer, when you plug it in and get a number, that's the second part of your point. So remember, you need 5 points. And they need to be distinct, okay? They need to be dots on the graph like this, right? I need to be able to see exactly where you got points on the graph. So that's how we do graphing quadratics.